Hello everyone, my name is Nguyễn Lê Hoàng Khải. In this video, I will presenting our team bonus assignment for Introduction to Database course. Our team has two members, Nguyễn Nhật Huy and I, Nguyễn Lê Hoàng Khải. The business topic our team choose is Dental Clinics Management System. In this part, I will briefly go over our business requirements and then walk through the ER diagram. The system's main goal is to support operations across multiple dental clinics branches, focusing on multi-brand management, patient record, service and medicine catalogs, treatment orders, and employee dependents. Out of scope are advanced payroll accounting, inventory supply logistics, patient self-service portal, and X-ray imaging iteration. The requirements descriptions were built on our past assignment, describing the entities and relationship used to construct the ER diagram. The table below summarize all the entities and relationship along with its attribute, data type, and a short description. Now let's go through the ER diagram in detail. First, each dentistry is identified by a unique dentistry ID along with dentistry name and phone number. Dentist has an ID, full name, salary, professional skill, and an employment start date. Since dentistry ID are only unique within a given dentistry, dentist is a weak entity with dentist ID as a partial key. A dentistry can employ multiple dentists, but each dentist works at exactly one dentistry, captured by one-to-many work at relationship. The managed relationship is one-to-one since each dentistry has exactly one clinic's manager. Each patient has a unique ID and basic information including full name, phone number, email address, and date of birth, and a derived attribute. Age can be calculated from date of birth, and a composite attribute full address consisting of house number, district, city, and in street. The system also manages dental services. Each service has an ID, service name, fee, and the professional skill required to perform it. Only dentists with matching skill are eligible to perform that service. Medicine informations are also stored as well, which with each medicine that identify with a medicine ID, including name, unit of measurements, and unit price. When a patient requests treatment, the system creates a treatment order recording the order ID and creational date, and the request patients and the dentist who create the order, represented by the one-to-many request and create relationship. A treatment may include prescribed medicine, each with its own quantities and dosage instruction, represented by many-to-many include relationship. A treatment order can also include multiple services. Since different services may require skill, individual dentists may be assigned to specific services within the same order, represented by the ternary many-to-many assigned relationship. Finally, to manage employee health benefit, the system record each dentist's dependents, including name, gender, and the relationship to the dentist. Dependents have no ID of their own. Their existence in the system depend entirely on the associate dentist, making dependents a weak entity.
Thanks, Kai, for breaking down the ERD. Now, building on that conceptual model, I will walk you through our relational schema. We have translated those entities into 9 specific tables, ranging from dentist and patient profile to treatment orders. I will also cover the key integrity constraints like foreign key and advanced business rule that keep our dental clinic data accurate and secure. Let's dive into the details. Let's look at how we transform our ERD concept into a concrete table, focusing on our primary key choices. Strong entity, uh, with symbol keys mapped directly to individual table. For example, patient, service, and medicine became standalone table with patient ID, service ID, and medicine ID as their straightforward primary keys. Next, composite attribute. In the patient entity, the composite attribute full address was flattened into individual columns, which are house number, street, city, and district for proper database normalization. Derived attribute. Uh, the dash uh, oval age is a derived attribute, so we omitted it from the physical table to avoid redundancy, as it can be calculated dynamically through the date of birth attribute. Next, uh, with entity, uh, a key design point is the dependent table. Because a dependent cannot exist without a dentist, its primary key is a composite key combining dentist ID and dentistry ID from the parent table. Uh, uh, we continue with mapping relationship into keys. Uh, the core of our schema design lies in how we handle the relationship between these tables. First, one-to-many relationship. Look at work as relationship. Dentist works at one dentistry, but a dentistry has many dentists. Therefore, a dentistry ID is migrated into the dentist table as a foreign key. As you can see, I did in here. Similarly, for create and request, because a treatment order belongs to exactly one patient and one dentist, it inherits patient ID, dentist ID, and dentistry ID as foreign key. uh, one-to-one about one-to-one relationship. For the managed relationship, a link between dentist and dentistry, we place manager dentist ID and dentistry ID inside the dentistry table as a foreign key, pointing back to the dentist table to identify who runs each brand. Here, with many to many relationship, uh, it is include between medicine and treatment order table and aside to relationship which link treatment order service and dentist. Uh, we transform it transform them into associative entity. The prescription tables act as a junction for include pooling order ID and medicine ID to form its composite primary key. The task table resolves the multi-way relationship among orders, service, and dentists, capturing the descriptive attribute like quantity and total fee at the exact point of intersection. For domain constraint, we ensure high data quality by making our primary and foreign key not known. We also enforce basic logic such as salary, medicine prices, and prescription quantity must be greater than zero, while service fees and task total fees must be greater than or equal to zero. Validation is also applied to dates like employment date and date of birth and formatting, ensuring phone numbers and email address are both valid and strictly unique. What truly secures our business operation are the advanced domain constraint. We have hard-coded 5 critical business rules into this schema. About clinic manager validation, a dentist assigned as a manager of a branch must actually work at that specific branch. Task skill matching. A dentist can only be assigned to a service if they possess the required skill in their professional skill pool. Regarding branch consistency, the dentist ID in a task must strictly match the dentistry ID where the treatment order was originally created. Timeline logic. A treatment order creation date cannot be earlier than the hiring date of the dentist who handle it. And lastly, if a patient is under 18 years old, the system will trigger a warning or require guardian info before allowing high-risk surgical procedures. And that's all about our presentation. Thank you for listening.